Good evening, all of you. I hope I am audible to all of you. Could you please confirm in the chat box?
Yes, yes.
Yeah. So today we are going to cover class, operator overloading, template, inheritance, and polymorphism. So let's start now. Hmm. So now we are focusing on the class. Yesterday I have told something related to class. Now we are trying to see its implementation today. So first of all, we are again going to create a solver. For that, we need to type this command. So the name of the solver is class. Now again, if you go inside this class, we see that there are other header files. So again, we are not going to uh, go through this header file. So we are removing it. Now today our focus is to using class. uh, we are going to uh, create a class and corresponding functions to calculate the pressure drop through a pipe. So we are trying to understand how to calculate pressure drop using classes. Although this pressure drop calculation we can perform using separate functions, but as we know that OpenFOAM is mainly based on object oriented programming. So understanding the very basic problem, that is the calculation of pressure loss through a pipe, will help us to understand complex classes that we are going to see later on, right? So let's start now. So first of all, we need to write what is the formula of this pressure loss through a pipe. So I am writing that formula, and we are going to calculate this pressure loss through our uh, concept of class. So delta P is equal to 128 multiplied by viscosity multiplied by flow rate into length of the pipe divided by pi and d to the power 4. So in C++ we write d to the power 4 using power function POW and then bracket name of the variable, that is diameter, to the power 4. So this is the formula for the pressure loss through a pipe. Now as I have said, we are focusing on the classes. So we are going to create a class. So first of all, we need to write this keyword class, and then what we are doing, we are calculating the pressure drop. So the name of this class is calc pressure drop. So whenever you define a class, the definition of this class will be inside this curly braces, and at the end we need to uh, use this semicolon to end the class definition. Now we are going to define the what is there inside this class. So as I have told yesterday that in class we have different kinds of accessibility, like how we are going to access the data member and the member function from the main function. So there are three modes: private mode, public mode, and the protected mode. So by default, if you don't specify any uh, uh, access mode, then it will consider it as a private mode. So let's write it now. I am trying to write a very general code so that you will be able to understand it. So it has three mode: private, public, protected. So I would request all of you to just follow the steps whatever I am doing in my screen, so that you will be able to uh, go through the process and will able to compile with us. And if some error comes, we will be uh, take we will be help you all to rectify that error. Right. So now, as I have told you, there are three modes. Now let's forget about the mode first. Now let's focus on this problem, that is pressure loss due to through a pipe. Now what are the variables? So first of all, we need to specify what are the variables. So obvious uh, so now, as of now, we are trying to define all the variable inside the public. Later on, we will change this variable in private and protected mode. So the variables are, so whenever we specify a variable, it has some data type, right? Like whether the values is integer or double or float. So here we are using scalar. Scalar. Then what are the variables? Variables are mu, length of the pipe, diameter of the pipe, and what is the flow. So flow, that is flow rate. Here we are not directly defining the flow rate, instead we are defining velocity, because the flow rate is nothing but area into velocity. So we in this class itself, we are trying to calculate the value of this flow rate. So now it is clear that we have defined this term. Now the second question that comes in mind is, all okay, we have defined this variables and its data type, but what is the value, right? So we need to create a function that will take the value of this variable. For that, we are defining a function. So the name of this function is void input value, right? So what are the variables? We have four variables, and we have defined the data type as well. It is a scalar. So again, here we are going to specify the data type. Do you have some doubts? Okay.
Nikhil,
Yeah,
so why are we specifying only the variable type inside that function handle?
variable type means data type,
On,
right?
no, only scalar, scalar, scalar.
So like we can define, so in the previous class we have discussed that scalar may contain the value related to double or float. That means
No,
what? Yeah.
that's correct, but why we are not specifying it as scalar mu, scalar L, scalar D like that?
So we can specify it, but since all has same data type, right, so we are defining on side by side. If you want to define it like that, then we need to shift the line, I mean we need to change the line, and each line is ended by a semicolon. So I can also do it for you, right. First of all I need to uh, okay, so let's see now. So as you have told me that why we are not defining, we can define it like that also. So I am just defining these two variables uh, in one line, and another two variable on second line. Now as I have told that we need to input certain values to it. So for that we need to create a function, right. So once we have defined this function, so it should be ended by a semicolon, right. Now what we see is, although we have defined this function now, but what is its definition, right. So just like I have explained yesterday, that yesterday we have mainly focused on normal functions, we haven't used classes. Now today we are using classes, so the function definition will remain same, but it should be preceded by the address of the class. So likewise I'm telling that yesterday what we have defined, this is the name of this function, so we have defined separately like this, right. So yesterday what we have defined, it's scalar a, then b, then c. Here we need to specify the variables also, right. So now this variable name, we are specifying it as mu. So mu is equal to a here, then we have length is equal to b,
Nikhil,
yeah,
your screen is frozen. Can you share it again?
okay.
And now it's visible.
Visible, right.
Yep.
Okay. Huh. Think where I am making the changes. Could you please wait for a minute? I think I have messed up with the files where I have
Yep.
made the changes.
And no issues.
Okay. I think we need to write it again. I hope the screen is visible to all of you.
Yes, it is visible.
Now, see, we have defined this variable again. Now we want to take the input, right? So for input, as we have defined this function, so this is the function name we are providing to input the values. Now we are defining it outside of this definition. So the values we are providing here. Hmm. So here we need to provide the variables also. Let's say A, B, C, and D are our variables. Now here it can be written as mu. So here we need to change one thing. So here we need to define diameter, because we are calculating the value of flow rate using area into velocity. So mu here is A, dia here is B, this u velocity is equal to C, and this length is equal to D. So as you can see now, yesterday we have learned about the functions. So it is also a function, but it is defined inside this class. So we need to define, we need to how a compiler knows that which function it is and where it is available. So we need to define its base class, I mean from which class it is present. So we need to copy this one and paste it here just before the name of the function, and there should be a double colon. That means that whenever you in OpenFOAM, whenever you go through certain uh, other header files or various solvers, then you see that there are a lot of functions that are written like this. So there will be some base class, then there will be double colon, and it is succeeded by a name of the function. Now these are the input values that we have specified. Now we see that we have specified the values, but in the formula we have q, that is flow rate. The value of flow rate is not uh, present at as of now, so we need to calculate the uh, value of this flow rate. For that we are creating another function. So the name of this function, as it has only one value, right? So uh, the function should not like here in is, you can see this input value have many values for different variables, but for variable but for flow rate it is returning us only one value. That's why we can choose a data type with some scalar or some return value, like we are defining here it as scalar data type. So scalar, then we need to define what is its value. So scalar q is flow rate. Now again we want to calculate what its value is. So again, normally if there is no class, we define it like this. So it should return what it should return. It should return this value, that is velocity pi by 4 into d square into velocity. Am I right? So area into velocity will give us the flow rate. So it is necessary that this q should be defined below this input value, because first we are taking the values, then we are calculating this flow rate. So this is, so we have defined this. First of all, we have defined this variable, and after that we have taken the inputs using these functions, and then we have defined the flow rate. So at last we are going to calculate the pressure drop. So what is the formula of pressure drop? That I have written here, right? So again we can create another function that will calculate the pressure drop. So that is also a scalar. Now again, we can define the values here, or we can separately define like this. So again I am separately defining it, copy it and paste. So here also we need to return some value. So what value it should return? It should return this multiplication 128 into mu we have defined, but we have defined this q function. So we need to copy it and paste it here. And then the length. So this is the numerator, and in denominator we have 3.14 into d to the power 4. So again I have defined it like a normal function definition, but as I have told you that it's a part of the class, so again we need to define its class, its base class, from where it is from where this calculation is needed. So again we have to copy the name of the class and paste it here, and then there will be this column, double column. So this is how we have defined, right, all the input parameters, the calculation of Q and the calculation of pressure drop, right. So the framework is ready. Now we need to define the values, what values we want to input. So for that, so when we, so compiler, it starts compiling its code from the main function. So first of all we need to define something that allows the compiler to move in this region of the code. So for that we need to take this class and paste it here, and we need to define some objects related to it. Let's say I am defining an object pipe 1, right. So once we have defined this pipe 1, then we can define uh, the input things. So pipe 1. Now how to define that input values? So input values, we can define it by using input function, input value function. So we need to copy this function and paste it here. So for pipe 1, like we are providing the inputs, and what are the inputs? We need to provide it in the sequence. So first is mu. Let's say we are defining it as 1e minus 5, and then we have, what is the second one is diameter. Let's say diameter is equal to 0.1 meter, and then velocity, let's say velocity is 1 meter per second, and let's say the fourth one is length. So length can be, let's say 2 meter. So this is how we have defined the input function, the input values. So first of all compiler will come here and it will check this class name. This class name is present, then it will create a object for this class. So object of this class is pipe 1, and through pipe 1 it will try to access this class, and it will go to this input value. So input value is here, so all the 4 values will automatically come here in sequence. Now once it comes here, it will again, so it will see a semicolon, so it will go to its definition. So when it goes in the definition, so the definition is here. So all the values, so automatically this value becomes a, this value becomes b, this value becomes c and d. So a will be assigned uh, to mu, and b will be assigned to diameter, c will be assigned to velocity, and d will be assigned to length. So through this object we are defining the values of the input. Now we are trying to see what is the result. For that we need to type info, so case 1, I hope you are also trying in your system. Now now we want to see the results, so we have to write this line, and it is inside the double quotation, so the compiler will just print this line as it is. Now the values will be, what will be the values? So the values will be, again we have to write pipe 1 dot, and now we want to directly know the value. So value means here we need to find this value, pressure drop, and then end line. Save it and run it. First of all, w clean, although there is nothing to clean for the first case. Now it is showing some error. So what is the error? So it is saying declared private here, right? Declared private here. So first of all, we need to change it. So as I have told you, there are three modes: public, private, and protected. So in the class, I haven't defined anything, whether it's private, public, or protected. So by default, it will take it as a private. So, and why this code is not running? Because this is the main function, and from this main function, we are trying to call this input value function, and also we are trying to call pressure drop function, and both functions are defined inside this class under private mode. Under private mode means only the member of this class will going to access the contents of this function. If you want to access anything outside, under which is under private mode, it will throw an error like this, and it will say that these things is private, this function is private within this context. So we need to change the accessibility. For that, we need to define here public. Now save it again. Now it has compiled. So now we have to type the name of the solver. The name of the solver is class. So it is saying that the pressure drop through pipe 1 is 0.064, right? Now again we can, similarly we can perform for many, let's say thousands of pipe. So what we can do is, we can just copy this entire thing. Now we are creating another object, that is pipe 2. So for pipe 2, we see that if the viscosity is different, and this value is different, so for this case, this is case 2. So the pressure drop through pipe 2 will be, so here we again I have to change to pipe 2. Here also I have to change it to pipe 2. So for the same class, I have created two different objects, and each object has initially, so basically practically we see that there are two different pipes, and we are trying to code things using the concept of class. So all we can do is, we can create a new object and just specify the value, and it will give us the results. So again going, so now it is showing the values for two different cases with two different input parameters, right? So the pressure drop through pipe 1 is this thing, and the pressure drop through pipe 2 is this, has this value. So we similarly we can calculate as many uh, results for this pipe as possible based on our this input parameters. So this is the most basic code that is related to class, and we have calculated the pressure loss through a pipe. I hope the coding is clear to you as of now.
Nikhil,
Yeah.
can you explain that compilation sequence of this .c file once again?
Okay, okay. So first of all, compile. So any code, the first the compiler uh, will target is this int main function. It will search for this int main function. So so there are various way to write this int function. Like in some of the code, it might be written like a void main. So you don't have to worry about this. You just need to focus on this main function. So this is the main function, and the compiler will start moving down from this main function. So first of all, it will see this thing. So first of all, it will try to see what is this. So it is saying that it is calc pressure drop. So if I directly define it as a calc pressure drop, then it will throw an error. But the compiler knows that the coder has defined this calc pressure drop, and it's a class. So it is not throwing us the error. And for every class, we can create the object. So class meaning of class is that we want to calculate the pressure drop, and object means object can be many. Like, so what can you understand by this code is, so through class we are trying to calculate the pressure drop which has same parameters. It won't change if we vary the number of pipes, but different pipes has different dimensions and viscosity, so that we are defining it through different objects of the same class. So under one class we are calculating different values of the pressure drop for different pipes. So uh, now it understand that it is a class, and it is its object. Once its object is defined, now using, then let's say we want to calculate the values, then whatever we want to calculate, now we have to access this part of the code using these objects. So whatever, let's say this function input, we want to calculate the, we want to know the values, we want to calculate this flow rate, we want to calculate this pressure drop, that thing we need to access it through this object. And for this object we are calling this function, and we, since we have taken this argument, we have taken 4 arguments here, so we need to provide 4 values here. So based on, now compiler will first check this line, and then it will go here, it will directly come here. So if there is a private, if we have defined, if we haven't defined anything, then it will consider it as a private, so it won't access. Like the first time we have compiled, it is showing us error that it is in private domain. So now compiler will come here, then again it will, it's a just a definition. I mean, it is saying that there is some function that is input value, then it will search where the definition of this input value function is, then it will automatically go to this input value here. So again, if we haven't defined this calc pressure drop, which is a part of pressure drop, so because compiler it starts, now first compiler knows is this class. So whatever we want to access, we need to access it through class name, that is the calc pressure drop. So now compiler knows that through this input value, it is coming here, and then it is coming here, and all a b c d is assigned to this known variables, the standard variables. Now compiler will go to the next line. What is the next line? Next line is this scalar q. Then compiler will move again, scalar q is not complete definition is not there, it will go here, here. Now after that it will go here. So it will calculate first it will complete the calculation for first object, then it will move to second object, then again it will go to input value, and then once this input value calculation is done, it will go to scalar and then pressure drop, and then again it come down. So it will try to have the calculation for each of the objects one by one. I think it's clear now.
Oh, yes.
Hmm. Now we are going to uh, uh, try to understand various other things here, like as I have told you that we have defined it under public. Let's say what happens if we define it under private, all the things. So we are, let's just copy all of things, cut it and paste here. Now we have changed the accessibility from public to private and try to see the results. Huh. Now it is showing us the same error that you have defined all the things under private mode. So from the main function, we can't access. So we are not able to access this thing. Whatever, see here we are trying to access this function, but this function is in private mode. Again, this pressure drop is in private mode. So it is not able to access. So that's why we need to specify this pressure drop under public. Now again try to check the compilation again. So we have only changed two functions. We have changed the mode of two functions from private to public. Now it has compiled, right? Because only things, so we are trying to access only two things from here: input value and pressure drop value, and that should be here only in the public mode. You can't define uh, the other things under private mode. Now this is about this one. Let's check the result also. It is giving us the same result. Hmm. I hope this thing are clear to you, how the compiler moves and where we need to define the functions and variables. So so there are three modes: public, private and protected. So whatever the functions we define here in each of the mode, that are called data function, member function. These are the standard words, and variables are called data member. So these are called data members and member functions. So this is related to calculation of pressure drop. Let's say I want to show you one more thing. Let's say we want to know the value of viscosity, right? So what we need to type? So we want to, if we want to know the viscosity value, then we need to type pipe1 dot mu and just try to check what it is showing. Now again it is saying that you have declared you want to access the value of mu, but this mu is declared in the private. So again, whatever you want to access from the main function, you need to define it in the public. So as soon as I define this scalar mu in the public, uh, now it can access the value of mu because it is now defined under public mode. So I hope this concept of public, private and protected are clear. So the private, we can't access it from outside, and uh, there is one more mode that is called uh, protected mode. That protected mode we will going to see later, because it can be accessed through the uh, derived class of the main class. So this is the main class, and we will going to learn about the derived class as well. So in coming lectures. So as I think this part is clear to all of you. If you have doubt, you can just post your doubts on the chat box, or you can ask us now. I hope there is no doubt. Let's move on to some other part. Uh, so we want to understand few more things here, like what is a constructor. Let's say the concept of constructor is also used in OpenFOAM C++ programming. So let's see what does that mean. It is also a kind of function which has same name as that of the class. So let's see it here. So we are again defining a function. So the function name is same as that of the class, which is this one. We have to copy it. Uh, so now we have to, now we don't need this function. Let's say we want to try, we want to define, we want to have the input in different way. For that, let's say we can comment this part. So here we are defining, instead of taking a instead of defining a separate function for taking the input, we are using the constructor, and the construction, the name of the function is same as that of the class. So again, here we are taking uh, uh, same inputs, that is mu, uh, that is all the four: mu, diameter, velocity and length. So again the compiler will come here. It will it wants to calculate the value of this pressure drop. Again the compiler will come here, but when it comes here, it doesn't see its definition. So first of all, we need to define its definition. So the definition will be similar to this one. Let's say we are taking the same value, we are copying here, paste here. Hmm. So this is the same thing that we are doing. So instead of this input value function, we are using the constructor function, and again since we are defining it outside of the class, we need to have this class in front of it. But remember, in this case, when we are defining the constructor function, we don't need to specify what is its return type or data type. So here we are not going to define whether it's scalar or void or something else. So this is the how constructor functions are defined. So we have commented this input value. Now how we are going to access this function? So accessibility is slightly different in case of this one constructor function. So here I have defined this pipe 1 and then has provided this values. So instead you can, so let's comment this second one. Why I have commented it? Because I have commented the input function here. So if I just run it, then it will throw an error because we are trying to access this input value which is commented. So that's why it's better to comment it now. So now we don't have to define the values like it. We can directly define this value, copy, in front of it. So there is no need of this line. So it is saying wide pressure drop input values. Pipe 1 pressure drop is there. No declaration matches input value, line 57. Let's comment out this part of the code. Now it has compiled, because the compiler is also seeing this line which is saying some input value which is not defined somewhere. So we need to comment that part. So again you can see the value is 0.064. So as you can see, I don't have to specifically define a function in order to input the value. We can directly specify the value without using a separate input function using the constructor, right? Like for example, here I have defined the object, and directly after the object I have defined the values. The compiler will directly go here in the compiler in this constructor function, and it will directly come here to get that values. So this is a slight difference between constructor and the normal function, and that you will able to see in various C++ CFD codes in OpenFOAM. Now we can again make certain changes. Let's say here we are not defining this. So again we are defining the constructor function, but we are defining it differently. Let's say we are not taking any argument. Let's say we are not taking any argument, right? So we need So in this case, what value it should take. So we can define such kind of constructor that is called a null constructor, because we haven't passed any argument inside it, so that is called a null constructor. So here also we have to copy it and paste it, right? So when we have pasted it, so we don't need this abcd. We can define abcd here. What is the, we can directly specify what is the value here. Let's say 1 e minus 4, diameter is 0.0 sorry 0.25, velocity is let's say 2.5, and diameter length is, sorry, the length is 3 meter. So in this case, uh, let's say this will be a case 2. So this is pipe 2, and what we are doing is we aren't using this input function, and we are directly calculating this pressure drop. And here we have a value. I mean, here we don't have a value because we have already defined separately in this constructor function. So let's try to run it. So now for the case 2, it is giving us this value because we have provided some default value. So you can see that in the first case we need to define a separate function in order to input the values, but by using constructor we don't have to specify a separate function. We can directly call this constructor function by defining the input of the variables just in front of just behind this object. And there is a third way that we don't have to specify anything, any value, because the value is by default available here. So we have defined the by default value. So in this case it will directly access these values. If we define it like this, it will access this value, and if we define it by using this input function, then it will first go this input value function, and it will try to have that value. So as you can see, there are three ways in which we can perform the uh, calculations using constructor, null constructor, and normal function. Now we are going to learn uh, now we are going to learn about pointers. What are pointers? Pointers are nothing but it's a kind of variable that holds the memory or memory address of a defined variable. So it's variable only, but contains memory of the defined variable. So how to define a pointer? So let's say we have defined a number scalar, let's say a is equal to 5.5. So we have defined a scalar is with scalar data type a variable with value 5.5. Now we are going to define a pointer. So pointer, uh, how we define the pointer is, first we have to specify the data type, and then it is followed by a star, and then the pointer variable. So let's say the pointer variable is x. Now we are setting what this x contain. X is nothing but it contains address of a, right? So a has this value, but where this value a values is stored is x. So x has the address of a. Let's try to print this. There is another way we can identify what the value of a is by using this pointer x. So if we run this one, this part of the code, see it is a is 5.5 and a is 5.5. But as you can see here, how we have defined this a is nothing but what is the value, what, so x indicates the address. So what is the value that is stored in that address is can be defined like this. So this is about the pointers. Now try to understand this concept of pointer using this example of pressure drop through a pipe. Now what we see, let's copy this class and object. So we have this object. Now we are going to, just like how we have created, so it's like this is scalar, so this is like a data type here and a is object here. So similarly how we have defined a pointer is by using the same class name. Here also, since it's a scalar, same class name, but here also we need to, since we are defining the pointer, then we have to specify this star, and then we can just type any pointer name. So we are just typing po pointer 1. So this is the pointer variable that we have defined. So now we have to again write it like this. What does pointer 1 contains? Pointer 1 contains address of a. So address means it is defined by this and symbol, and we have to define pipe 1 here. So let's try to print the value through pipe 1. So we have to define this symbol, that is pointer 1, that is arrow towards this pressure drop. Now again it is showing the same value what we are getting earlier, that is 0.038. So this this line of code you will going to see very often when you go to the source code. That's why it is very necessary to understand what does a pointer mean. So pointer holds the address and it will point towards the value of that variable that is stored inside that address. Or similarly, it can be uh, different. It can be written in slightly different way like this. Like here, star. So star pointer, then you have to press the dot. So again, try to compile it. For this is case 3, let's say. See, here we are getting the same value through different definition of how we are trying to uh, calculating the pressure drop using pointer variables. So this part you will going to see very often in the OpenFOAM source codes. So that's why it is necessary to understand the concept of a pointer. Now we are going to learn about operator overloading. So now create a new solver. So again we are clearing this part of the code. Now why operator overloading is important? Because generally in CFD we deal with various kind of physical quantities like scalar, vectors, tensors, and you know that you can't add scalar to a tensor or vector to a tensor or scalar to a vector. Similarly, vector to a tensor. So the multiplication of or the direct addition is not possible, and but it carries certain important information which can't be directly added. So that's why it's necessary to understand the operator overloading. So this problem we are going to analyze using the concept of a complex number. For example, we have studied that complex number, it contains a real part and imaginary part. For example, 2x plus 3i, sorry, 2 plus 3i, but this 2 is nothing but the real part and 3 is nothing but the imaginary part, but we don't add these two numbers directly. So it contains certain meaning, right? So that's where this operator overloading is important. So what we are trying to do is we are trying to add two number, means two complex number. Hmm. So again we want to uh, again we need to start it from the very scratch. So first of all, we need to again create a class. What is the name of that class? So we can create a class. See, class, the name of this class is, we are defining it as a complex number. So it is defined like this. At the end we have semicolon in class definition. So this is how we have defined this class. Now again here we have three modes: public, private and protected. So let's try to uh, perform the operations under public mode first. So first of all, the things that comes in mind is what are the name of the variables. So obviously, the name of the variables in a complex number would be a real part and the imaginary part. So we are defining it like scalar, real part RP, and imaginary part IP. So we have these two scalar variables RP and IP, real part and the imaginary part. So now what we are trying to do is we are performing this operator overloading. So here what we have to do is, so here we have to define the operator overloading using this keyword, that is the name of the class complex number. Then what we are trying to do is we are adding complex number, addition of complex number. So for that we need to choose the operator. So the so we need to type this keyword operator, and then we are adding it. So we have to choose plus sign, and then we need to define the second complex number. So the second complex number is, how we are defining is this way. We are trying to define is using reference. So we have to use this and symbol. So this operator overloading tells us that the complex number, two complex number are added and the operator is plus sign. So we are basically adding two complex number. So first of all, the complex operator, now what we have to do is we need to perform. So we have just defined how the operation should be. The operation is addition. Now we want to uh, define it separately uh, in the operator function. So first of all, we need to copy it and paste here. So we have the complex number plus the complex number, right? So here again we are trying to define it outside of this class. Then again we need to define from where it is coming. Just like functions, we need to do it for this operators also. So again this two double colon. So the double colon will not come here, double colon will come here. So this is how it's defined. So you can't argue that why it should not come here and there. So this is the way these things are defined. And for the second number we are defining is num2. So, and sorry, here we don't have to do. Now we are going to perform this complex summation. So again we have to take this complex number and we have to define, so with the name of this is the class name, and we are trying to define a object. So object is sum. Now we can perform sum dot. So for example, we are trying to how we sum a complex number is through summation of real parts separately and summation of complex parts separately. So we are trying to do the same thing here. So the real part sum dot rp, we are defining its initial rp that this complex number contain, and the second rp that we are providing. So it's num2 dot rp. Similarly, this is for real part, and same thing can be done for a imaginary part. So now here we have added this complex number. So what we have to return is, we have to return its sum. So this is the function we have created, which has same name of the class, and it has been operated using addition operator to add another number. The another number is number 2. So this is the initial number, and this is the second number, and the initial number we are going to define it now. So once we have defined, now again, just like we have defined the first case, that is in classes, similarly here we have to again in the main function we need to define the class. So the name of this class is class number. Then we have to specify what is the uh, second number. So the second number or the first number, whatever it would be, we have to define it. So so let so we are defining here the second number. So the for first number, we can define it like this. Actually, I am getting little bit confused here because it's slightly off, but I will try to make you explain the things. So here we need to define the first variable, that is complex number. Just like what we have defined earlier. So here RP becomes IP becomes B. Now this is the first complex number that we have defined. So we can pass it through like this. So number 1 is here we have defined 3.0 because it's a scalar, and then 2. Similarly, we need to define the second number, that is number 2. So what is number 2? 5i. 5 and 1. So we have two numbers and we need to perform the summation. So we are creating another object, summation. So what does summation contains? It is summing two number object that is stored in number that is stored in object 1, and number that is stored in object 2, like this. So let's try to print the values. Let's see what it is showing. I am hoping it will show some error because maybe something I have done wrong. So like while you are code in your problem, it's quite obvious that you will get confused. Like I have confused now little bit. So don't just stop your coding. Just try to code whatever you think, and then when you compile, you will get to know what are the errors that you are going to see. And similarly, you can rectify the error one by one. So this is one of the standard practices that you have to do even if you become is expert of this coding in OpenFOAM, because you might miss something or just confuse about two different concepts. So these things you need to uh, do it even if you are feeling little bit confused. Real part and then imaginary part. So imaginary part, uh, we have a term that is I that we need to here specifically defined. Let's try to see what is the answer. Hmm. Now, as expected, it will show some error. So first thing is, so you have to start it from the top. So it is saying that there should be a semicolon. So first complete the semicolon. This should be semicolon, and then complex number end. Here also there should be a semicolon. Now what is the error? No declaration matches. Uh, so let's say you have to just comment this part because we are not calling this constructor function as of now. Now it is the error, that error has been removed. Now it is saying so. Let me check why this is happening. function equal to complex number double. Let's try to change it to again same error is coming. Okay, so I think let's proceed further. I will get back to you regarding this part of the code, maybe sometime afterward, because I need to cover a few more things related to classes now. Let's move on from this part for now. Now we are going to explore some other characteristics of this one, uh, characteristics of object oriented programming. So one of the concept is inheritance. So what do you mean by inheritance? So we are going to explore it using this part of this code. So for that again we need to uh, create a name solver. So again we are deleting this part of the code. Now inheritance meaning we are trying to inherit the information from other part of the code, right? This is the meaning of inheritance. So for inheritance we are trying to take an example of pi. So in the first example we have gone through the pressure loss through a pipe. Now we are trying to calculate one more parameter, that is called Reynolds number. So through the example of a single pipe, uh, we are going to calculate Reynolds number, and that is pressure loss through a pipe. And if we write the expression of this pressure drop and Reynolds number. So just I'm trying to copy it. So this is the formula for pressure drop, and for Reynolds number formula in terms of this flow rate is 4 by pi into rho multiplied by flow rate, then divided by diameter into mu. So this is the formula for Reynolds number in terms of flow rate Q. But if you can clearly say this two expression, there are certain things that are very common. For example, diameter, viscosity, and flow rate. So the common terms are flow rate, viscosity, and diameter. So you can just uh, imagine that if we create two separate class for example, in the first case we have created a class for calculating the pressure loss. Now we are calculating another class in order to calculate the Reynolds number. But while calculating the both parameter, we see that there are certain parameters whose calculation is quite common. So that's why we are trying to define a different class which contains common information for both the class. So that class is called a base class, and the other two class are called derived class. So so if we want to exchange the information, it's like we are taking the information from base class. So that's why the concept of inheritance. We are trying to inherit the values from the base class to the derived class. So this is what the meaning of this concept of inheritance. So now we are going to just copy the same thing. Let's copy the same first example and we will try to modify from this original code. Hmm. So this is the original code for calculating the pressure drop. But now we are not. Uh, we now need to calculate uh, the value of Reynolds number. So it's quite obvious that we are going to create a second class. Copy and then paste. So we are what we are calculating? We are calculating Reynolds number here, right? So when we are calculating the Reynolds number, we see that there are certain parameters common. So that's why we are trying to calculate a one more class that contains the common information of pressure drop and Reynolds number calculations. So let's say that class is uh, let's say fluid. Let's say flow in a pipe. So this is the class we have created. Now what are the common terms we need to define in this class? So the common terms are, so mu is common, and then again u is common. So again we are not directly defining q, we are defining u. Velocity, so velocity we need to paste it here. Now what are another parameter? Another parameter is diameter. So diameter we need to define here. And again we are not calculating pressure drop here. We are calculating pressure drop uh, in in its separate class. So we can delete it. But the calculation of q, that is the flow rate, is common in both. That's why we need to define it here. So it's quite clear that the common things are defined in the main class, that is called a base class. And these two classes are called derived class. So what are the things that are not needed here? We don't need this thing. mu would we don't need mu, we don't need this parameters also. Diameter, okay, we need length here, we don't need q here. Similarly for Reynolds number, we don't need this mu, so we can delete everything because it's very new kind of class. So we are going to now code it how to perform uh, calculation of Reynolds number and pressure drop through a pipe to inheritance. So for that, so like this is in the public domain, we are providing this information, and we have defined the scalar that is common, and we have, again we need to, we can define it here for better understanding. So just remove the private now. We can just play with this shifting of this variable from private to public and public to protected in order to understand it more clearly, but as of now just take it public. Now again we need to input the variables, right? So what are the variables that we need to input here? We don't need to input every variables. We need to input only three variables: mu, u, and diameter. So we can remove the fourth one. So this is for viscosity, this is for velocity, this is for diameter. Now similarly we can do it for Reynolds number. No, first we will do it for this pressure drop. Again we are defining it in the public mode. Let's delete this part. Now again, so only the calculation of length uh, is needed. The value of length is needed in the calculation of pressure drop. So that's why we are defining here. So this pressure drop contains values. So input values will be pressure drop, right? Where is this is flow, this is pressure drop. So what is the input that is needed to calculate the pressure drop? uh, we need only length. So length we have defined here. So just comment this constructor as of now, it will create a confusion. Here we need a scalar which is rho. Now again scalar Reynolds number. We have defined a function to create the Reynolds number, right? Now what we have to do is, these are the input that are needed. So we have one input variable for this one. Similarly, we need to have input variable for this length. So here we will having only one input variable. Similarly, we will be having only one input variable for this. Uh, so again, if we just take three input function with same name, it will create a problem. That's why we need to change it. So here we need to change it to input row, because we need row here. Then here we need only input length. So I hope this is clear that in the main class, that is base class, we have defined the common function and common parameter, and in the specific class that is called the derived class, we have only defined the parameters that is only needed in the calculation of pressure drop, not in the calculation of Reynolds number. So now we can define uh, the definition of this term, that is void input scalar, this scalars. So for that, again we need to copy this one and paste it here. So again we are defining it outside, so again we need to have the class name in front of it. And what are the values? Common values are mu, u and diameter. So these are mu, u and diameter. So this will be required here, and then there is, let's comment this constructor as of now. Now the formula of this pressure drop will remain same, and then there will be a, so again this is a definition of Q. Now this Q, the class has been changed. So Q we are calculating in the flow in pipe. So you need to change this here. So this is how we are calculating the flow rate, and for pressure drop, it's calc pressure drop, which will not change, and then there is one more for Reynolds number. So it's calc RE. So calc RE, how we have defined is, so now we want to calculate this function, the values from this function RE. So here we have to define RE, and here we need to define what is the value it will going to return. So it will going to return this value that we have written here. So I think we have defined all the parameters. I think we haven't defined. Let's check what it will show. So first of all, again, what we want to calculate now. So what we want to calculate the pressure drop through a pipe. So we have to define that function. I mean that class name. So this is calc pressure drop. Just remove this thing. Calc pressure drop. Object is pipe 1, and then uh, so we want to calculate the pressure drop. So we are using this class, that is calc pressure drop. So calc pressure drop is here. So in calc pressure drop, what we are doing is, first we are trying to specifying the values. So this is pipe 1. So what are the values? Here we have defined 4 values, right? So we don't, so we have to change first of all the definition. We are not calling a constructor here. So this pipe 1 we need to calculate. So using object of this class, what we are trying to access is, we are trying to provide value. So what value we should provide? We should provide this input value. So here we have viscosity 1e minus 5. Then we have diameter and velocity. So diameter is 0.02, viscosity let's say 0.05, and then we need to info this. The pressure drop is, so again the pressure drop is pipe 1 dot, we have to choose this function pressure drop. Where is that function? This function. And similarly for pipe 1 is, similarly we can calculate the Reynolds number for pipe 1 is this one, RE. Now if we run this, we see that uh, error will come. Why error will come? Because we haven't defined the value of row and length. So here we have 3 arguments only. So lot of errors are coming here. First of all, line 41, it is indicating where the line, where the error is in line 41. So here it's saying it should not come. Let's remove this part of the code now. Now most of the error has been removed. Now it is asking A was not defined, B was not defined. C was not defined, mu it's unknown, Q is not defined, and so on. So we are going to tackle one by one. First of all, this is the calculate pressure drop. So we want to calculate the pressure drop. So first of all, here we are trying to uh, so here we have only provided the input. We have not provided the velocity, sorry, we have not properly calculated its value. So first of all, we need to define what is the value of this scalar. So let's say that scalar we are trying to define here only. So when we define a function definition here, so we need to have some values. So we are defining some variables. So e, that e should be, so here the length should be equivalent to e. Similarly, for rho we are defining f. Now here we have to define the values. So pipe 1, so we have defined the input value, but for pressure drop we need to know the length, and how we got this length is using this one. So we need to define this length. So length here is, let's say, 2 meter. Similarly, we need to define it for this row. So again, this row can be uh, calculated by accessing this row function, input row. Let's say its value is 1. Now try to run that part code. A was not declared, B was not declared, C was not declared. By so because here we have directly copy and pasted, so here we need to change. Here we need to define what is A, what is B, and what is C. Similarly, there might be another function definition. Okay, first try to run it, then see how many errors are removed. Now that ABC error has been removed, now it is asking mu, q and diameter was not declared in this scope. So again we need to check it. Let's comment this for a while. Calc RE. Hmm. So calc RE. Okay. Hmm. See here, I have directly written q. So it is not recognizing what q is. It's a function. 3.14. Okay. So I think time is over now. I will get back to you to this debugging part of this code, that what mistake we have done. I think uh, I think you all have got this fair idea of how to code the particular part of this code, and I think the error is not very big. I think if you can try of your own, you can make through it. Still, we are going to debug that error tomorrow. So you can leave now. If you have doubt, you can ask. So we wanted to inform you that as we are going very slowly, so we would like to have another class before the weekend. So we are expecting another 1 hour class either on Tuesday or Wednesday or Thursday. We will let you know, and if you have some uh, your suggestion on what timing that class should be, you can just comment on the chat box, or you can just later on communicate with us through WhatsApp. So I hope from the coding point of view, you might have learned that how we can code the things, and I hope you will try to debug the code on your own, right? So I will also do it from my side. So that's all for today, as the time is over. We have crossed 2 hours. So you can just leave now. We are going to meet before in the weekdays also. Thank you all.